Hi everyone, this is Byte Relay. Welcome back. We are back again, and today we have an interview with Dmitry Dolgov. Hi Dmitry, how are you?
Hi. Yeah, I'm fine. Hi, everyone.
Dmitry is known for his contributions for Postgres and some very insightful blog posts and talks on different conferences. Dmitry, can you say some more about yourself?
That's probably the most hardest question I usually get in various interviews. Like, tell a couple of words about yourself. Like, what the hell am I supposed to talk about?
I don't know.
Yeah, but
Do you do something
no.
beside databases? What?
It's hard, Postgres is actually a significant part of my life. Somehow it became like this, although, I mean, maybe it's not that clear from the outside, but yeah, it's something I associate myself quite strongly, although right now I'm trying to do it a little bit differently, but nevertheless, okay, we can start from the very beginning. So usually when people are talking about themselves, they're saying what are their hobbies, right? So my hobbies are usually I'm pretty excited about database in general, whereas especially I'm into the science behind this, computer science, and I've pretty much excited when there is an interesting white paper to read, for example. Another my passion is actually Linux kernel as a community, as a project, because well, it's also very interesting stuff, especially when it goes around very deep topics, like especially like performance analysis or something. And the third passion is a sort of somewhat a secret thing because not that many people share it, but I'm pretty much into the Haskell as a programming language. And usually people at this moment asking why and so on, and it's hard for me to explain. It just happened like that.
Yeah, it's just fun. It's clear. But this is like three so big different topics like operational systems, databases, and functional programming. They each one is immense. And how do you like pick that? Today I am a operating system hacker. Today I am a database man. Today I want some monads. How do you choose something from these three directions?
It's a hard question because usually it boils down to the time management. Although not in a way like usually people from the business are usually telling us, yeah, you have to be super efficient and so on. It's mostly about whether or not I have some interest in some area. But there's a trick actually. I have noticed that over the last probably years, Postgres community became slower and slower in terms of reviewing the patches, which means that
Mhm.
every single time when I get response from the hackers, I'm doing some databases. When I'm not getting response from the hackers, I'm probably doing something different.
Oh, that's very interesting trick. I will try it myself too. Uh,
Multitasking.
wh- when I don't have a response from hackers, I'm like scratching my head and waiting and where is my response? Okay,
It was
good.
like that for me a couple of years ago. That's true, exactly in this way. But now, since I'm trying to sort of split my efforts between Linux kernel community and Postgres community, I'm somehow a little bit more relaxed about this.
Mhm. Got it. As a like man of science, as someone who is reading a lot, how do you learn new stuff? How do you pick which papers or books or videos or whatever courses do you take?
Well, I mean, in our era of media overload, it's actually easy to get an information, and the question is how to find out something
Hmm.
worth read or worth watching. Um, so I don't have actually a solution, or I don't have any particular strategy. I'm just like skimming through the well. Nowadays, I'm trying to get rid of most of the media I use like a social media, but I still have some set of like subscriptions to various blogs and so on. And I also reading every now and then digest, for example, from ArcSci, from the computer science area and mathematics area. But it's all still very noisy. It's quite a lot of noise in there. So at least in terms of all the scientific topics, especially like something hard like computer science or mathematics, I found it's very useful to actually go and pick up some reasonable books about the topics, especially if they are not necessarily like, for example, I don't know, a graduate student's material from the university. It's also useful because then you can just pick up something And you know that people are actually getting taught by these manuals, by these books, and you know that you're getting some information. But there are also very interesting books that are actually sort of trying to explain various hard topics in simple words. It's not necessarily a popular science in this sense. It's more like a digest of a modern news and information from various topics. So the recent example I've got, I'm absolutely fascinated by this one, is there is a project called Quanta magazine. Maybe if you've heard about this one.
No.
It's well, and they have a lot of media when they post and on. And but one I'm talking about now is actually they have two books, but those books you definitely heard about because even like Bill Gates was recommending the first one. I think the first one is about the physics, and it's called Bob and Alice in the Wall of Fire or something. I haven't read this one yet, but the second one about mathematics and the modern mathematical development called the Prime Number Conspiracy, and I've just recently finished it, and it's just amazing. It's essentially a set of essays about really, really modern, crazy mathematical stuff, but they are somehow managed to not dump it down. What happens with the usual when usual journalists are trying to do some media coverage about science? No, they're really talking to scientists. They're really doing this journalist stuff, and they're really trying to deliver the big meaning. What are they talking about? Like unimodal forms or some, I don't know, differential equations of all this stuff. And I think there is almost not a single formula even in this book, and still it's very deep, but at the same time very understandable. So that's what I found very exciting, and probably that's the easiest way to do actually. Just like get some books that you see, you get maybe a recommendation about this book, and usually since it's like a finished work, you know, it's from the beginning to the end, there is a logic behind the book. You know that you will get this journey and you will get something out of it.
Sounds great. So we will put a link on this book under the video so everyone could just see themselves. You mentioned science a lot. Do you write scientific papers?
I was doing this at the university.
Do you plan to do it more?
That's an interesting story because the thing is that it happened to me that there were a couple of topics that I have rediscovered for myself over maybe a decade or something. So for example, when I was a teenager, I was pretty much into the chess, and then I somehow, I forgot about this completely. And then even before pandemic, when it became popular, I somehow picked it up chess again about 2016 or something, and since then I'm really crazy about this. And maybe you have seen actually they're remembering me on the conferences because I'm carrying around this chessboard. And that's something similar what happened with the science papers. I'm not writing yet, but I'm thinking about this actually because I was doing this in the university. We were doing a very interesting work about mathematical modeling of various stuff, like a computational modeling. Mm-hmm. And there are a couple of papers from me and my supervisor or something about, what was it, 2015, 17 in this area, about actually quite cool stuff about the modeling of the heart system and heart walls and everything. But yeah, I have stopped doing this from one point of view. At the same time, this fascination is still there. And I see that there is actually surprisingly, if you poke some scientific topics, it's easy to find something where you can contribute. It's almost like Postgres. It looks scary and almost unapproachable from the outside, but there are some. I've heard, for example, recently that mathematics is riddled with errors, and it turns to be true. There are a lot of things that are actually written and proved, and then some smart student came up on the lecture and says, "Well, there is a mistake there, you know about it." So this type of stuff, it's actually relatively easy to do. Of course, I'll come up with some new interesting algorithms of new properties. So
your next paper will be about what? What about?
Well, for example, I think the last blog post I have managed to write, I have one coming probably soon, hopefully, but the last one was about p-square algorithm, which is a quite interesting thing. It's an algorithm how to compute quantiles in a minimal amount of memory, as less as possible for embedded systems, for example. And it turns out that there is not that many modifications of this algorithm, for example, for running Windows. And for example, in this area, there are some naive approaches, and that's what I was trying in this blog post. I was trying some different variations about this, how to make this running window, how to modify this algorithm to make it calculate quantiles over the running window, because that's actually where it can be.
Variants of T-digest or P-digest, something like that.
No, but it's how to say. It's also it goes in this direction. You write about those weird data structures, and it's sort of an approximation. You write, so it approximates actual quantiles. The trick is that even when we are calculating normally, for example, when we're taking library and calculate something that is called like an exact quantiles, it's still an approximation because of the definition of it. An approximation when, for example, quantiles do not exactly fit into the border between the elements, you have to still approximate. But yeah, this algorithm goes even further, try to approximate it with as small data sets as possible, small data points. So yeah, but it doesn't. It works on the whole data set, so it's a little bit inconvenient. So I was thinking about this, and maybe something like this will be really fascinating for me to actually try my hands on. Of course, it's much interesting and much probably visible if you would write some scientific paper about the databases, and then you can send it to some cool journal or something. But of course, it's much harder. So I'm not sure if I'll manage to pull something that's like this out.
Sounds very cool, but how do you think like databases? Is it about mathematics? Do you see a lot of math in Postgres? Do you see like what kind of math is there?
All kind of math. That's the good part. To me, database is actually a sweet spot between practical approach and pretty theoretical things. It's like it's a point where everything comes together. And from one point of view, yeah, you have to implement this stuff. Like there is a lot of complications around this, and I really like, for example, I think Robert was mentioning this one. So there are a lot of great ideas out there, but just because of historical reasons, not all of them would be implemented in Postgres, just because how it is. But at the same time, it doesn't mean that you cannot think about this or try to experiment, right? And answering your question about what kind of algorithms could be there for databases, well, obviously, for example, what I was talking recently about is different indexes and indices and their different variations.
But it's not math. Math is like numbers and like equations, and
that's the point. That's one side of things. But what happens nowadays, and it's somehow, I don't know, it's probably a popular trend, so maybe it's a hype, but it's already quite long time with us, not necessarily that it's a hype, about learned data structures, where people are trying to use leverage, whereas, for example, neural networks or some machine learning algorithms can figure out how to, not necessarily how to, for example, create an index, but how to generate an optimal data structure for a database. And there, it's one of the sites when you can get a lot of math getting into it. But very interesting thing I have discovered recently, I think a couple of years ago, is that there is a completely different site when you can apply some math to the databases. And that was absolutely mind-blowing. I was watching one interesting talk. I can also recommend it probably afterwards. I can give you a link about this. There was one guy who is doing, I think his name is David Spivak, and he's doing a lot of practical category theory in researches. So, category theory, it's something that usually people call abstract nonsense. So like, how do you even apply it to the database, right? He managed to do this. And here is the point, here is the gist of it. He was doing a research or like more of a survey. And following his resources, about 40% of IT budget of like an average IT company, people are spending on data integration, which actually makes sense. That's what we see usually, right? People are trying to integrate different systems, and those systems are talking usually different languages, different formats, different data formats. And you have to somehow manage to put them together. It's a hard job. And the thing is that most of the time when you're getting an errors in this area, you're getting this incompatibility errors, different data structures, formats, and so on. And category theory, that's exactly mathematical apparatus that allows you to simulate one world and how it happens when you will try to put roles from one world, for example, from relational database into the another world, for example, documented-oriented database. You can simulate how different rules would behave, how different constraints would behave. Or, well, actually, the better example would be, for example, they were showing some, what was it, an XML structure when you're trying to just organize your data. I was trying to migrate this data. Yeah.
Sorry, there was small hiccup with the network. It was like 15 seconds or so, and I lost where he was. It's
Okay,
like
when you lost me?
yeah, like you're trying to migrate data from somewhere, and he was describing like like theory category help us
Mhm.
to cope with data integration problems?
Yeah, so I was actually probably too fast, so I needed to first explain the context here, because where category theory shines is when you have two different, let's say, worlds, or in their in this definitions or in these terms, it's going to be two different categories, and you would like to set up and establish some comparisons between those categories. Usually there are some mathematical things, for example, like sets or posets or something like this. But in the research of David, it was actually a database and data structures that you wanted to either integrate or migrate or something. And that's what was actually happening. So you're saying that instead of mathematical objects, now my categories are databases and data structures. And then if I, for example, migrate data from one format into another format, it's actually hard to understand what will happen until you will actually perform this migration, right? And then you figure out, I forgot this constraint, for example, or something, and now my data is broken, I have to do migration again. So using category theory, they were actually trying to prevent these type of things even before the migration took place. So they were essentially building this model of both worlds, and they were figuring out how constraints are going to work. Constraint that you have in one world, for example, in a relational database, how are they going to be working when you put them into another world, for example, some logs, data structures, and so on. So that was essentially the whole like a gist of this idea. And then there were like a sense.
The idea is that you have like some magic apparatus that understands your data and can mutate it, transform it, and like understand source format, understand destination, and can magically do a transformation. It sounds
Not
impossible.
It's not, no, that's the thing. You're not making magical transformation, but using this magic, you verify if this transformation is going to work or not. You verify if your invariants from one world are going to work into another world, or you have to do some more work on this transformation. So that's the point. So the whole idea was to prevent situation when you made the transformation, and at the end of the day, you realize that something is not working there. Some constraints, for example, are not possible to implement or something of this sort. So it's only about validation. It's not like it's going to make this transformation for you. No, of course not.
Got it. Okay, sounds quite complicated, quite interesting. And let's get back to like more popular and simple things. Machine learning, it's everywhere, like artificial intelligence. Do you expect that ML or AI will change database landscape, or will we doing like C code for years? It's the same
Well,
way
I
we were
mean,
doing it.
I'm pretty sure that SQL will not go anywhere because it's like lingua franca of the working with the data in general. But at the same time, I'm also sort of already at this point convinced that to a certain degree, this whole ideas will transform database field, but probably not in the way we expect. Probably not going to be some intelligent robots going on and like moving data around, but probably it will be something that will help us make databases a little bit faster without, without actually having a DBA tuning this database to the
So it's
least,
all
to the
about
maximum
performance.
possible performance. Mm, well, I mean, isn't the database all about performance from the starting from the first place? I mean, you can put everything into an Excel
No,
spreadsheet or in a text file, and you're going to be fine with it if your database is small enough, right?
no, databases should help engineers to create systems. It's like a component that should like fit, not just fit needs, but create novel ways to engineer, create novel ways to think about data, and novel ways to design systems. And
That's true, and this part will not go anywhere, at least to my understanding of this world, because that's the thing. When we're talking about machine learning algorithms and all this type of stuff, what this approach good at is about essentially it's a solve an optimization problem. So it's essentially just an operator to solve to find some optimal solution for some particular problem. It's not a creativity in this sense. It will not create something completely new for you. At max, it will create probably a combination of two already existing things or three already existing things, something of this sort. So it's good to address problems when there are a lot of different options on the table, and you just need to understand which of those are actually optimal. But creativity, or for example, like what you were saying about this understanding of how to make a system simpler, or like how to put all those things together, yeah, that's at least I think that in the future it still will be there and still be required, and pretty much unaddressed or not unsolved problem.
Actually, I just saw that sometimes like performance or quantity can transform to quality. So if we get like quantum leap in performance, we can allow to design new kind of systems. For example, if you have like 1 or 2 transistors, you can build a radio. If you have 100 transistors, you can try to make a calculator. If you have 1 billion of transistors, you can make a, I don't know, cell phone or something.
Yeah, definitely. It's this emergency pattern. We could observe it quite frequently indeed, when essentially the system that you're build or you're creating is more than just like a part. It's simply like a isolated parts of it. When you're creating using different things, you put them together and there is something emergent, something new out of the system. And in terms of performance, well, there are a lot of examples like this indeed, when you just can do something essentially completely new when you get to a new level. And well, it's actually also a little bit strange example, but still people are quite often talking about quantum computing, for example, and it's also a situation when it theoretically, this computational model theoretically opens completely new horizons for us, even for databases, for example.
Quantum
And
databases? Sounds cool.
sort of quantum algorithms for databases. I was also surprised to learn about this, but apparently there are such things like, for example, a Groover algorithm that allows us to do a sequential scan in a square n complexity. Like, what? Seriously? But apparently it's a thing. So the trick is that you're not going to check every record using one operation, one at a time. The idea behind this algorithm, it's very hard to get like an intuition, to grasp an intuition on this algorithm, and I still don't understand it myself, unfortunately. But the idea behind is that you can entangle those records together in batches and then check them all at once. So somehow this type of magic is possible in quantum world, apparently, and it's not like it's not hand waving. It's a algorithm that is proven mathematically, at least to our current assumption. So obviously in the practice it probably will be a little bit different, but at least in the theoretical, from the theoretical point of view, that's supposed to be okay.
This sounds very much like Bloomfield or hash table. So we kind of have a tool for this.
Sort of.
Okay, let's switch again into another area that I wanted to ask you. You was serving as a commitfest manager in Postgres community, and you was like doing patches for Postgres quite a lot. Can you compare these two? Like one is like more social or about interacting with humans, and other role is like more interacting with systems. Which one did you like more, and can you compare something about it?
Well, the thing is that I probably like more everything that has nothing to do with social part of things, because actually the thing is, I obviously enjoy working on the Postgres by developing various interesting things, and not necessarily super useful, or not necessarily super robust, because people quite often complain about my patches, unfortunately, but it makes a lot of fun to me. And I'm actually surprised that not necessarily about commitfest management duties. Generally speaking, I mean, you obviously also observe this quite a lot. You also have a lot of experience in this area. You see how community is working in this sense. So I've got really interested recently into trying to understand how Postgres community works. And what are the, let's say, disadvantages, or not even disadvantages, like what is how to make an introspection about how community works actually, and commitfest management duties was actually one part of it, because usually that's one thing that people actually do not like to talk about that much. It's actually extremely social part of things, but there are different interesting ideas that actually probably could help with understanding, with getting some understanding of some basic properties of this as a whole, like as a system. And that's what I'm saying is that's an extremely hand waving at the moment. So it's an extreme philosophy, unfortunately, although with still with some amount of mathematics on top of it. That's why I like it. That's why I was saying that probably everything what I see, even the social problems that I see, I turn it into the mathematics. So that's probably my weird part.
That's absolutely fine in our community. So now that you have this introspection of Postgres community, do you think it will be the same in 10 years or 15 years or 50 years? How can you like predict something about Postgres community?
That's a good question. It depends on the data that I haven't collected yet, because I have a project at my hands about crunching the mailing list data, and it turns out there are some researchers that are actually doing the very same thing. They're trying to understand how Postgres is working using just trying to analyze mailing list, because it's a very interesting source of data actually.
Mm-hmm.
And the thing is that, I mean, a lot of people I was talking to, or I heard they were mentioning this before, that community is definitely changing itself. How community is working, for example, like patches before the time they were conceived to the moment when they're getting committed, this time frame is getting definitely longer than it was like a couple of years ago, right? And it's just visibly longer. So there are definitely some differences or changes that happen in under the hood, and it's just not really clear what's happening. One interesting data point in the sense, for example, was this recent blog post from Peter Eisentraut when he was essentially comparing the amount of contributors over the last couple of years. And he came to the conclusion that it didn't change that much, actually. So it was about 400 something over the last 3 releases. And interestingly enough, he was pulling out his experience, and he was saying that in the past they were doing something similar, and the situation was also the same. The level of contributor, just purely number of people that are working on Postgres source code, is relatively stable over the years, which makes me think that it's a very, well, a little bit troublesome situation, because obviously Postgres as a project is getting more and more popular, right? It attracts more and more people, more and more users, more and more people who actually would like to contribute something.
Mm-hmm.
So if you think about this as a system with an input and a feedback and a pushback, it's going to be from one side people are actually using Postgres and providing some input. They may be creating new patches or something. And on the other side of the system, the community who tries to cope with this somehow. We're trying to review patches, we try to like somehow address the feedback, fix bugs, and so on and so forth. And the problem is that those two processes, they are not really well balanced in this sense. I guess my impression was that a couple of years ago, they were much more balanced than we have now. And now, because of the popularity that Postgres is gaining, this balance is getting even more out of hand than it was before. And that's why community is getting some sort of overloaded in a sense. And it actually makes total sense, because I was really curious about the stuff and I was searching for various science papers. And what they're saying is that based on the GitHub data, for example, the growth of the community goes using the power law, which means essentially like a degree of something. So like, exponential or something, whereas the community power to review something is essentially a network. So it's at max like linear complexity, which means that it's not, there will be always a point in time when there is much more to do than it's possible to do, which means that at the end of the day, community have to decide what to do and what to not to do. It's some sort of an obvious idea, an obvious thing, but at the same time, it has a very interesting implications on the community as a whole. Because now we have a choice, we have an idea that we have to actually make a choice, in which direction to steer the Postgres, right? And it's absolutely not obvious. There are various policies here applied and people are doing it in a very different way, but at the end of the day, it's an open source project, right? So you cannot just tell people what to do, which means that the original question you were posing about what are the predictions about the future of this whole system, honestly, I don't know. It looks like there are certain
It seems, Dmitry.
Can you hear me?
Yes, sorry, there was a hiccup again in my network. You was telling about predictions when I lost connection. Something with my network, internet providers. So you say that honestly I don't know, and then something interesting. And what was it?
So the thing is that it's hard to predict because I have not yet even collected any kind of data, but there are certain problems that are definitely clear there about the scale and how community is going to address the scale of the incoming popularity, let's say this way. And at the same time, there are different ways to addressing this. And for example, what I really like is I like to address, I like to compare different communities. Like for example, what we have Postgres community versus kernel community, right?
Mm-hmm.
In the Linux kernel community, we have this different separation, interesting separation when everything is separated by the subsystems. So there is a, I don't know, IO subsystem, there is a various file systems, there is network subsystem, perf subsystem, BPF, whatever, which makes the scale problem a little bit easier because now, you don't have to find a committer to review your patch because this committer is busy doing some other part of things. Now, there's a pool of people who are working on this particular problem on this relatively small system or subsystem in this sense. We don't have this in Postgres. In fact, in Postgres, yeah,
Is it
you wanted to mention?
possible? It's like so interconnected system.
Exactly, the database, the whole nature of this database, or maybe it's not even necessarily the nature of the database itself, but the way how we think, we people from the database community, we think in a stateful way in this sense. That's why usually the things we create are quite interconnected, maybe because it's the nature of the problem we try to solve, or just maybe it's the nature of how we think, but nevertheless, in the Postgres community, it's very hard to apply this approach, that's true. So, which means that most likely solution to the scale problem has to be different. So, and the question is whether this problem even has to be addressed. Maybe it's not even a problem. Maybe it's something that will just sort it out naturally. Because, I mean, not everybody is complaining. I mean, time for the reviews of patches are getting longer, but some people are okay with it.
Some people are okay, but it's from the side, it looks like committers working mostly on something that they were working like for years, and many community patches are stolen. Okay, so that was very insightful conversation. Thank you, Dmitry, for doing this interview and sharing your knowledge and intuition with us. Thanks a lot.
Yeah, thanks a lot for having me. I hope after this conversation, people will not think about me as a crazy scientist or something like this. No, I'm pretty sane person.
It's just fine to be crazy. What's the problem with it?
That's true, completely true. I agree with you.
Like, it's a whole culture of being like unusual and doing unusual stuff, and that's about hacking, and that's about inventing technologies. Okay, thank you so much, and goodbye.
Bye.